right, ladies and gentlemen, welcome back. We were going to do in the series servo next, but we're actually going to skip through that. Well, actually, not going to skip it. We're going to do one thing first before we go at servo, and that is going to be the potentiometer and using our switch case statement to control our potentiometer, or vice versa, actually, using the whatever, you got it. So let's create a new circuit. And let's go ahead, and it's been a little bit for this, possibly. So we're going to get out here our breadboard. Where'd it go? Oh, there it is. Our breadboard will go out here. Our Arduino Uno will go out here. And we're going to do something weird, I guess. What we're going to do is we're going to use, if you click on your breadboard, we're going to rotate it so the red strip is up. And we're only going to do that because that's kind of the way I have it in the video here. Oh, well, sorry. So our positive rail will be to the top. So let's go ahead and then get out here a potentiometer and an RGB light. So the RGB we will put here, and then our potentiometer, if we can find where that bad boy went, is right here. We're going to put right here. Should be close enough. It's going to actually end up being, I think, a little bit different in the video as I do this in real life, but it should be fine enough. All right, so let's go ahead and get wiring. It's, like I said, potentially been a little bit here. So our cathode for our RGB lights is going to need a resistor going to the negative rail. And then we are going to make red, which if you do that, red is going to be 10. And make sure you change your wire color to red to match. Blue is going to be, as I'm looking at the thing in real life here, blue is going to be 8. And then this should be green, which is going to be 9. So now the reason this looks a little bit funky is because on the RGB bulb that I have in front of me, it's actually possibly that I put it in backwards, but that's okay. We're going to work that out. It'll be fine. So blue will be 8, green will be 9, red will be 10. That's what's important. So now for our potentiometer here, we are going to need to run this side to the black rail. And that's going to be a ground wire, so that'll be black. Our red wire is going to run all the way over to 5 volts for our positive. And then our middle pin. So what the potentiometer does, and we'll show you this in a little bit, is the potentiometer registers a value anywhere between 0 and 1023. And if we pause for just a moment, what you should be able to see here in real life is you can see on my potentiometer as I turn the knob that you get a value that changes. So as it goes, when I turn it left, it goes all the way to 0. And when I turn all the way to the right, it'll go up to 1023. It's a little bit weird to see in kind of reverse there, but that's okay. Okay, there we go. So let's go ahead and go back in now to our Tinkercad and finish our circuit. Sorry, I guess a little bit all over the place today. I just wanted to kind of show you what it was exactly what we're trying to do before we go and we try and do it. So we have the bulb we've done before. We've wired a bulb. It's pretty straightforward, goes to a digital pin. The only thing we're missing here is we need to run a wire from ground up to our negative rail that is a black wire, because that is the negative, black's negative. That's how it goes. So the only other thing here is to get that value between 0 and 1023, you run a wire from the middle wiper pin of your potentiometer, and we're going to run it to A1 on your Arduino. We're going to make this one white for no other reason than that's the color that I had when I wired it in real life. You can kind of see here, if I switch back, it's definitely not the easiest to see, but you can see my wiring here in real life, and that's just a white wire. That's all. So this is our wiring for the circuit. Hopefully it's a little confusing looking. I'm sorry, but if you follow it closely, it should be fine. Pause the video here, get your wiring all set, and then we'll come back and we'll write the code. In this case, we're actually going to write the code in the Arduino environment, and then we're going to come back into Tinkercad to test it. As a matter of fact, we're going to open our code window right here just to get set. And of course, we want that. And let's go ahead and continue with that. Like I said, pause and make sure your wiring is all set, and then we'll come back to this. But I am just going to continue. So what we're going to do is we have our switch statement that you should have just completed. This is 100% done, I would hope, by this point in time. What we're going to do is we're going to go ahead and do file, and we're going to save this first, just to make sure you don't lose it. And we're going to go then to file and do save as. So we're going to save this as potentiometer. We'll call it pot1. And we're going to go ahead and hit save. I already actually have something called that. So you won't have all that. It'll just say, yes, okay, sounds great, and save. But we want to just reuse what we already have. And just as a double check, go ahead and Control A to copy all of that, or select all and Control C to copy it. And let's just go ahead and paste that all into Tinkercad real quick and just do a quick start of the simulation. And we click our serial monitor, and we get the same exact results actually as we saw in our regular thing when it did. All right, so we'll stop the simulation. We're good. Assuming everything works, then we're going to go ahead and actually start modifying. So in our thing here, we actually have a very minimal modification in this. So we're going to go and we're going to use something to comment right now our main switch statement. We don't need that yet. So if you do the / and the star, everything up after that turns gray. Find this thing where you said end of the switch statement, end your comment right there. So end of the loop ungrays. And to get our value, what we're going to do actually first is declare two values. So our potentiometer pin is going to be A1. That's what we just plugged it into. And then our potentiometer value is going to be just semicolon. For right now, we're not going to worry about it, but we are going to copy that. So our potentiometer value, we're going to take this variable, and in the beginning of the loop here, what we're going to do is we're going to do an analog read of our potentiometer pin. And then we're just going to go, we actually can just copy. And as opposed to printing message, we want to print out whatever the potentiometer value is. So let's go ahead and see if this will work in Tinkercad. Again, the purpose of doing it here is that it highlights and everything is all super fun and good. But go ahead and do Control A, select everything, and Control C to copy it. And let's see if we can go ahead and put that into Tinkercad You can see everything should be fine. Let's go ahead and start our simulation. And we do indeed have some values coming in. Let's stop this, see if we can actually access this stuff as we have our code one. Oops. It looks way worse when I drag it, doesn't it? All right, so if we are going to start our simulation, and it actually in Tinkercad will work if you drag around the potentiometer, which I think is super cool, by the way. So at this point, you should be able to get a value between 0 and 1023 on your potentiometer in Tinkercad. So what I want you to do is I want you to then translate this into real life and see if you can make this work. And then as a second part of this video, we're going to then use the switch statement to actually do some things. So I will end this video right here. You should have a working potentiometer at this point. If you do not, please come see me. I will help you. Otherwise, I'll see you in the next video very shortly.